All right, I think I got this recording all started. So in this video, I'm going to cover how to run post layout simulations. This is something that we've asked you to do for your final project. At the moment, there's some technical issues with the library setups, so I had to make a workaround. And so this video is going to go through how to implement the workaround and then how to do all the other stuff. So the first part of the video will be setting up the workaround for the technical issues. And then I'll talk through how to run parasitic extraction on your layout. And then I'll talk about how to simulate your design using the parasitic extracted version of it instead of just the schematic version of it. Once we get the technical issues resolved, I'll come out with a nice little PDF document as well, but I'm not going to do that until we get that fixed. So the first thing you need to do is download this file that I'll provide on Canvas called, let's see, ls. Okay, you need to download this file, extractionfiles.tar.gz. So that'll be provided on Canvas, and then once you have that, you can move it to where you start your cadence. So I'm going to use the move command. So I'm going to move this to ~/GPDK045. That's where my cadence stuff is set up. And then now that I'm done with that, I'm going to change directories to that folder, my cadence folder. And then now if I list the files, you'll see that that extractionfiles.tar.gz is right here. So now I need to extract it. So I'll do this by typing tar space and then dash xvf space and then put in the name of the file. And then I'll hit enter. This might take a second to run as it extracts all the files. Okay, and now it's done. And now if I list out the files in this folder, you'll see that now there is a PBS and a QRC folder. So these are normally things that are in the remote cadence libraries that we'd have you reference, but there's some file permission issues right now, so we're just gonna have you download it, put it in here. The other thing that you need to change is this pvtech.lib file. So I'm gonna type in get space pvtech.lib, then ampersand, so I can edit it. So I'm going to open it up. And then you need to make sure it should have this define line in here that you set up when you set up the library or set up this cadence library. So make sure that this says GPDK045. And then, yeah. And then you want to put the path to this PBS folder that we just looked at. So if I change into this PBS folder that we just extracted and then do pwd to show the path, then I can show this path right here. So I can just copy this, go back to here, paste it in, save the file, and I'm good to go. So now all the setup stuff should be done. Next thing to do is to go to your directory where you start cadence and then start it up. Excuse me. Okay, and then once this starts, now I'm going to show you my cell that I'm working on. So I made this design here just for demonstration purposes. And basically, it's just two cascaded inverters, minimum sized inverters. So I'm going to close this out. And then if I open up my layout, here's my finished layout for it that passes DRC and LBS. You can see it looks very ugly. I tried to intentionally make this layout very bad so that the parasitics would be worse. but it didn't work out the best, but whatever. So you can see I have these like serpentine paths here to try to create more resistance, and then these big blocks of metal are to try to make parasitic capacitors. So don't do your layout like this. Do it much nicer. This is just for demonstration. So to do the parasitic extraction, the first thing I need to do is go up to where it says Pegasus and then run LVS. And so I'm going to set up LVS like I normally would. So this is the directory where I like to run my LVS. Go to rules, select the necessary rules. And then the one thing you need to change is at output, or in the output tab here. If you go down, you'll see this little box that says additional output, and it has this checkbox that says create Quantus input data. So check that, and then leave this as the default, which is SVDB. This is going to create, sorry, whoops. Okay, this is going to create the data needed for Quantus to run post layout extraction. And so then I'm going to hit submit and overwrite, wait for that to run. And I have a clean LVS. So now I can close this, and then now I'll go up to Quantus. And so you should have this Quantus tab in your layout. If you don't have this Quantus tab, then what you need to do is go back to your terminal and go to your home directory, so cd tilde, and then do gedit.software space ampersand. If you open up this folder, this is all the different software that is set up on your Linux machine. And so you need to add this line Quantus at the bottom, just like this. So if a tab's not showing up, then open up this .software file, add Quantus, save it, close everything down, log out of the Linux machine, and then log back in, and then you should have it. So yeah, once you've done that, then you go to the Quantus tab, choose this option that says run Pegasus-Quantus. And this should auto-populate with the name of your design. So I call this post layout. It should have the directory where that SVDB file was created. So this directory should be just the path to wherever your LVS run data was stored, and then /SVDB. So if it doesn't auto-populate, then fill that in. And then this Quantus techlib should be referenced to that pvtech.lib file that we edited earlier, just like this. And then technology should be GPDK045. So if you have all of that in place, you can just hit OK. It's going to pop up with a box of different options for parasitic extraction. There are a lot of options. There's a lot of different kind of customized, like different things you can do to customize how it's run. There's a lot of different options. A lot of this depends on what you're trying to accomplish through your post layout extraction. If you end up working in a company, then you're probably going to learn a lot more about these types of options. For now, we're going to keep things pretty basic. So up at the top, you want to make sure that your technology is selected as GPDK045. Make sure you select the RCX typical. Okay, you could use worst or best if you want. This is just like typical case parasitics, worst case parasitics, best case parasitics. So we're just going to do typical. You can leave all this the way it is. Scroll down, and where it says output here, you want to select extracted view. And then it should have the library and the cell for what this is. So if this doesn't auto-populate, then fill this in correctly. And then it would probably call it like AV_extracted for the view. You can name this whatever you want. So I just named it extracted. Just remember whatever name you give it. All of this you can leave default. If you want, you can do extract MOS diffusion resistance. I'm going to check this option. I think it'd be good to do. It's not needed, but you can decide if you want to do it or not. And then go up to the extraction tab. And here in extraction type, we're going to select RC. So the extraction type controls what parasitics it extracts. So R only only looks at parasitic resistances. C only looks at parasitic capacitances. RC is both. RLC looks at parasitic resistance, capacitance, and inductance. Because like traces can have inductance to them, like you learned in your EE311 class. So we're just going to choose RC. You can leave it as micro, or you can leave all this default. Where it says cap coupling mode, change this to coupled, and then fill in your ref node as whatever your ground node is. So for me, I have VSS. It's kind of like my ground node or whatever. So I'll put VSS there, and then make sure that full chip and all nets is selected. And then this filtering tab, you can leave as default. This just filters out like what parasitics you extract. So you can extract all of them, or you can filter out the really small parasitics to make it run faster. So just leave this as default. Leave net listing as default, and run details should probably be just left as default, but you might want to note where the run directory is in log files just in case you have any issues. Yeah. And then you can also, if you want, you can use multi-processing and then use a number of processors. This should default, I think, to 1. If you want, you can do like 2 or 4. I wouldn't go beyond that though, because you might get in trouble. This just makes it run faster. So probably use 2 would be a good number. I'm going to use 4 right now for the tutorial just because I don't want to waste you guys' time watching this run. So then you can hit OK. And I've already done this once, so I'm just going to overwrite what I did before. And then it's going to pop up this little box, and you're just going to wait. And while we wait, I'll explain a little bit. So parasitic extraction is just looking at your layout. And like in your schematic, you just had the transistors. You didn't, and then it assumed that all your connections between your transistors and your resistors and whatever was ideal. And so what parasitic extraction is doing is saying, hey, this connection here actually kind of looks, it's like a polyresistor basically. So I'm going to extract the resistance value of this and add it to your design. And then, with all these metal layers I have right here over each other, this is going to form capacitors. So it's going to extract those capacitors and add it to your design. And that's what it's doing. Okay, so this finished up, so we're just going to hit close. And then go to your library manager. And now you see that there's an extracted view in your cell, or this should be called whatever you named it. So I named it extracted. You can open it up. And if you look at it, it has kind of it'll probably open up like this. It has an abstracted view of your layout. And then if you zoom in, you'll see a bunch of these little P capacitors and P resistors. So these are parasitic capacitors and resistors. If you hit Shift F, it'll show them, and you can zoom in, and you can see the values of each. So a lot of the capacitors will be really, really small. You can see here I have a pretty good sized resistor for this kind of serpentine poly resistor that I made. Yeah, so you can just kind of look around at those if you're curious. And I'm going to close this. And so now we've successfully set up the files that we need, and we've run the extraction. Now it's time to simulate our extracted design. So here I have my test bench, just simple test bench, capacitive load, pulse input, my supplies. I'll open up my ADE Explorer. And then in here, if I want to run if I want to simulate my extracted or some of my design with the extracted parasitics, then I'm going to go to Setup and go down to Environment. And up in this Switch View list, somewhere before schematic, I'll just put it right before, you want to add the name of your extracted view. So I just called it extracted. So I'm going to add this into the list. And what this is doing is that when the simulator runs, it's going to look for different views to simulate. And so it's going to see that you put in extracted before schematic. So if it sees any extracted views for any of the cells, then it'll use that instead of the schematic for simulation. So you can just hit OK. Go ahead and run it. And once it's finished, it'll plot. And then this isn't real interesting, just looks like kind of normal. So I'm going to change this replace to append, which means that when it plots, instead of replacing the old traces, it'll just add on top of them. And then I'm also going to go back to my environment and remove the extracted. So then I can compare the two. So now I'll run it again. And then now it plots V in and V out from both my extracted view and my schematic view. And if I zoom in here, you'll see there isn't much change, but if I zoom in real close, there's a little bit of change between the two. And this is due to the parasitics. So in this case, the parasitics did almost nothing, which means I did a bad job of creating parasitics in the layout, but that's okay. So yeah, depending on your design and your layout techniques, you might see more change, you might see less change, but that's how you can get a more accurate view of how the design will work after the layout is done. So with that, you can now go and run your post layout simulations. I am going to show one more method for setting up the post layout simulations. This is not needed for your project. It's just something that's done in industry a lot more, and I think it's helpful to know about because as you get more to the advanced bits of using cadence and running simulations, it can be very, very helpful, but you don't really learn it at Iowa State much. So the other way you can do this is to, if I go back to, or if I go to my test bench here, I'm going to go File, New, Cell View, and I might have made a video on this already. I'm not sure. Or I've showed some people this, I think. So cell leave the same, and then where it says view, I'm gonna do config tab, and it should auto fill out this stuff. And hit OK. It's gonna open up this form. You're gonna choose here we're gonna choose for our top cell schematic. Or actually, wait, sorry. No, what we're gonna do is we're gonna go down to the bottom here. We're gonna use select schematic, and then we're gonna hit use template at the bottom, and then select you should see Spectre from this list. And hit OK. And then OK. And this will auto set up this config view. And so what this config view is doing is it's looking at your test bench schematic, and then it lists all the different things. So we have the output capacitor, the DC sources, or this VDC cell, the input source is the V pulse cell. We see the NMOSs, and the thing that's called post layout was my schematic that I made and layout that I made. You can also do tree view to see like here's the top one, and then you go down, here's the post layout schematic, and then in that are the different MOSFETs. So yeah, so usually I just use table view, but then what this does is you have the same sort of like view list as we had earlier, where it searches for so it searches through each cell in this order, and if it sees that view, then it decides to use that view. So you can see for CAP and VDC and vPulse, it's using the Spectre view. For our other ones, it's using schematic view. And so if you want to choose, instead of using the schematic view, to use your extracted view, then you can right-click, go to Set Cell View, and then go to Extracted. And then you can hit this little, it's going to say Update Needed. You can hit this little Recompute Hierarchy. It's like this little paper with an exclamation point. And hit Enter. And that will save it. And so now this is set up to use the extracted view instead of the schematic view. And if you have a bunch of cells, you can do this for each cell. You can choose what you want to make more ideal or less ideal. There's a lot of things you can do with it. But so now I'm going to close this, and then I'm going to open up my Maestro for simulation. And I'm going to right-click on where it says like it has this little arrow and has the name of the test. I'm going to right-click and hit or click on design. And then where it says view name, instead of doing schematic, I'm going to choose config. And I'll just choose, I guess it forces you to use read. Okay, I'll do config. And so now when it runs the simulation, instead of just looking at the schematic, it'll look at the config file that you made. It'll see what each thing is supposed to, what view each cell is supposed to use. It'll set that up and run the simulation. So I'm going to click OK. And then if I run this simulation, it will run the same way as we did earlier when we added the extracted term into that view list. So again, this is not needed for your final project. It's just optional information to know. Yeah. So with that, I'll call this video a wrap. If you run into any issues, please let me know. There might be some technical issues. I think it should work. If there are, I'll work with you to get them resolved as quickly as possible. And yeah, and I'll come out with with a little bit more concise PDF guide once things are resolved. So thank you. Have a good day.